How are you?
Hi, David. How you doing?
Good, David. How are you?
Good. Hold on just a sec.
Okay.
Okay, David, we thought from going over this stuff last night, what we'd like to do is have you go over with us again. Let's see, it's starting 18? Starting 18 through like 23 or 4. These we write the equations of a line giving these different information.
Okay.
Okay, so then there was a couple more on the other page that we wanted to do. The other ones you did pretty well on.
We'll just go through in the order that you would like to do.
Alrighty, so why don't we start that then?
Okay. How do we figure out what the slope and the y-intercept is here?
Well, the y-intercept is 45, isn't it?
No. In other words, what form do we need to put it into in order to figure out?
Y equals mx plus b.
Okay. So that's your first goal, is to get it into that form. And then whatever the constant is, that's your y-intercept. But it's not what the constant is right now. It's what the constant ends up being by the time you solve for y. So what's the first step in solving this equation for y?
You could minus 5x from these sides.
Okay, so what's the next line?
It'd be 5x minus 45.
Hold on. Back it up. We're solving for y. So we're going to leave the 9y there.
Yes.
So how do we move the 5x to the other side?
We minus it, so it would be 45 minus 5x.
Okay. But if we're trying to get it into mx plus b format, well, let's switch those two terms. Do you see where that's the same thing?
Yes.
Now what's the next step?
You could divide 9y and 45 by 9.
Yes. In other words, we're trying to isolate the y, so we have to get rid of anything that's around it. And I do that by dividing both sides by 9. Now, when I divide both sides by 9, I can write it like that, or I can do it like this. I can just do each term by 9. Same thing. What's the next line? In other words, we have to simplify that.
I'm just figuring that out.
Okay.
It'd be the calculator automatically puts it into a fraction, but wouldn't it be 5 over 9 plus 5 equals y?
Almost. What's this again?
Would it be 5 over 9?
What's this?
Or would it be 9?
What's this thing here?
A negative, so it would be negative 5 over 9.
Okay. That's not trivial. You will lose all credit on the problem if you get the sign wrong.
Yeah.
You won't get any credit at all. Okay, so 5/9 is not the same or even close to minus 5/9.
Right.
So it's minus 5/9 x, we can write it like that, plus 5. Now that we have it in y equals mx plus b format, what's the slope?
It's negative 5 over 9.
What's the y-intercept?
5.
Okay, so whenever you have, if you're given the equation in that format and there's a coefficient on the y, at some point we're going to have to divide everything by that coefficient. So if I wanted to instantly know the y-intercept, I would know it was 5 because I know I'm going to have to divide by 9. But since the problem said give us the slope and the y-intercept, then the whole goal really is to put it into that format, precisely that format. In other words, if I go back a step here and decide that I'm going to divide both sides by 9, and I write it like that, well, make sure you can take that and separate it into mx plus b, which means separating that into two fractions, that fraction and that fraction. All right.
David, does it make any difference that when he starts, since he wants to isolate y on the left side, is there any benefit in trying to put the y over to the left side, 9y over the left side, and the remaining terms on the right?
I have mixed feelings about that. And where they come from is that to put the y on the left, you're going to have to change its sign and make it minus 9y. And there's nothing wrong with that. Let's go through and let's see if that's easier. In other words, you don't really have to have it in y equal mx plus b. You can have it in mx plus b equal y. So there's no real advantage in putting the y on the left side. And here's what happens if you try to do it. If we go back to the first step, and we decide, well, we want to get it exactly this way. I'm going to put that on the left side. And now I got to move everything else to the right. Now I got to divide by minus 9. So I do end up with y isolated on the left, but now I got to handle the negative sign in the denominator, which isn't a big deal, but I got two negative signs over there. My tendency is to stay away from negative signs if you can help it. I would rather leave the sign positive and leave the y on the right than bring the y to the left and have to switch the sign on everything. Actually, I guess if I start from here, then I can bring the 9y to the left, making it minus 9y, move the 45 only to the other side. You know, I'm not real sure that there's any difference. It kind of depends on the person, if you're the kind of person that always wants your primary variable on the left, then that's probably what you should do. If you're trying to replicate this exactly, then go ahead and put the y on the left if it makes it easier to understand.
Okay, yeah, so he can just pick, it doesn't make any difference. And that's the way he went, and he came up with the right solution, so I guess I'm not going to screw around.
Yeah, okay.
All right, so let's go to 19 then, David. You got yours over
Okay.
here. Sorry.
That is a minus 2y, is that correct?
Yes.
Okay. Here, the only thing they want is the x and y-intercepts. They don't want slope. What format is this in, Patrick?
Isn't it mx plus b equals?
No, it isn't. mx plus b is this. We don't have y isolated here. This is called standard format. And when it's in standard format, the one thing that is particularly easy to do is to find the x and y-intercepts. What's the x-intercept and what's the y-intercept?
y would be 3, and the x would be 2.
Well, let's look at the x-intercept. What is true about y on the x-intercept?
It's always when x equals 0.
We're talking about the x-intercept.
Oh, sorry. It's 0.
Y is equal to 0.
I
don't know what the coordinates of this thing is. It's some x, but I do know that the y is going to be 0 because I am on the x-axis. So the way I can figure out what x is going to be is just to substitute that 0 in for y. What do you get? You get x equal 2, which is what you said. Now let's go back and figure out what the y-intercept is. How do I get the y-intercept? Without...
Plug 0 in.
Yeah, put 0 in for what?
X.
Okay, so what do you get when you do that?
3.
No. Correct? When you put 0 in for x, you're left with minus 2y equals 6. So what's y equal to?
Y is equal to 3.
Solve this equation. What's the next step in solving that equation?
Divide each side by negative 2.
What's 6 divided by negative 2?
Negative 3.
Okay. So the y-intercept is at negative 3, not positive 3. Again, you would have gotten no credit for a positive 3. There's your line.
Okay, do you have that now? Now,
this is kind of a unique problem. This is almost the only kind of problem where you don't have to solve for slope. That's the problem where they merely ask for what are the x and y intercepts. Notice that I never did solve for slope. I don't know what that slope is. I don't care. The only thing I care is what the x-intercept is and what the y-intercept is. And the only thing you need to do for those is to plug in 0 for the other value. But you have to be able to solve that equation properly.
So David, when they have the standard form formula, which we've got up here is x plus b, y equals c, that just helps you identify an equation that's similar to 3x minus 2y equals 6, right?
Well, I could put this equation into y equals mx plus b. In other words, let's solve it. I'll move the x to the other side. Then I'll divide by minus 2. It's important to understand that this is the same equation as that. It's just in a different format. Right. It's the same straight line. And I could have gone to all that work to put it into y equal mx plus b, but notice what I now know. I know the slope and I know the y-intercept. I still don't know the x-intercept. Mm-hmm. So there's no advantage into manipulating this equation into slope-intercept format. It's unnecessary. They're not asking about the slope. They want to know both intercepts, so I'm better off leaving it in standard format and just solving it straight away.
So that's what I'm saying. When you see the equation is in the standard form, and they ask for the answer that they did here, all you have to do is go ahead and solve the equation. You've got all the information you need.
Yeah, I mean, sometimes you need to put it into slope-intercept format, but sometimes you don't. Most of the time you do. In other words, if we look at all these questions on here, this one's in slope-intercept format. That one is not. That one is not. So it kind of depends on what you need to know. If you need to know the slope and the y-intercept, then the easiest thing to do is to put it into slope-intercept format. But if you need to know both y and x-intercepts, this is actually the best format to have it in, because it's real easy to substitute 0 for one of the terms. The moment you substitute 0 for either x or y, that whole thing disappears.
Right. Does he have, is there a question there that he needs the point slope formula then? Point slope form?
Well, let's do it with
Because
this.
he's gone over slope intercept form and the standard
Let me
form.
make it up. Let me make up a problem.
Because these are about, I figured out that these are probably about a little bit more than 1/6 of the grade.
Yes, these are very important. Very important.
Maybe.
These are linear equations. Every one of these is a linear equation, whether it's in standard format or slope-intercept format. I'm going to give it to you in standard format, and I want you to tell me the slope and the y-intercept.
Okay, that's standard form.
You don't even need to know that that's standard form. I'm just going to give you that equation. What is the slope and what is the y-intercept? So what do I need to do to this equation?
You need to put in y equals mx plus b.
Let's do it. What's the first step?
Okay, you're going to want to minus 8x on each side.
Okay. What's the next line?
You're going to have negative 3y equals 9 minus 8x.
Okay, I have a choice. I can write that like that, but it really makes more sense to write it like this, does it not?
Yeah.
In other words, I'm getting ready for slope-intercept format. So let's write it like this. What's the final step?
Now you just divide each side by negative 3.
What's the slope and what's the y-intercept?
The slope would be negative 8 over negative 3.
Simplify. What's negative 8 over negative 3?
Would be negative 2 and 2/3.
No? By simplifying, I meant that's the same as 8/3. So the slope is 8/3. Now, would you lose a point there? I think so, probably. You wouldn't lose full credit, but you'd lose a point for sure, because you haven't simplified it. Negative 8 over negative 3 is 8/3. What's the y-intercept?
It's 9. I mean, sorry about that.
What is it? What's the y-intercept?
It's 3. Negative 3.
Negative 3. There's a definite tendency for you to drop signs.
I'm going to put a string on his finger.
Yeah, I don't know what to say, how to impress upon him the importance of the sign. Perhaps maybe the very first thing that you should try to think of rather than the number. In other words, when you see this, rather than figuring out that that's 3, figure out the sign first. I don't know what that 9 divided by 3 is, but I know it's a negative because I got a positive divided by a negative. So if you figure out the sign first, now figure out the number. Now 9 divided by 3 is 3, and I've got the right answer. All right, let's see. That was 19. All right, 20 is a classic, if they could only ask you one question on the test, it would be 20. This is the one thing you absolutely have to be able to do. Figure out what the equation of this line is. It's the first step.
Once you put it in point-slope form?
Yeah, if you know point-slope form, that'd be perfect, actually. That's actually the best way to do it. But a lot of my students aren't nearly as comfortable with point-slope format as they are slope-intercept format. Do you know point-slope format?
Yeah, a little bit. Isn't it y minus y1 equals mx times x minus x1?
Okay. Use this slope and point to solve this. In other words, this is a good format to use. Point slope, we have a slope and a point. So that sure makes sense that this is what we would use.
So would it be y minus 1 equals 2 times x minus a minus 3?
Perfect. What's x minus a minus 3 equal to?
Negative 3.
Hold on. What's x minus a minus? Get rid of both of those minus signs.
Oh, so it would be plus 3.
Yes.
Okay,
now, that would actually be an acceptable answer to this problem. No, it wouldn't. I notice it says it wants it in slope-intercept form. So how do we put that? We're not in slope-intercept form. We're in point-slope form. How do I convert this to slope-intercept form?
You could add 1.
Okay. Is that slope-intercept form?
No.
Not quite. It's close. What do I have to do?
You have to
Distribute.
you have to
Distribute the 2. You got to get rid of the parentheses.
So what would it be?
y equals 2x plus 6 plus 1, which is plus 7.
Okay, so that's in slope-intercept form now. Perfect. We've got our answer. I want to do this problem the other way, the way you were doing it the other day. I think it's useful to know multiple ways to do a problem. I really do. I'm not trying to confuse you, but let's figure out how to solve it using just slope-intercept. Slope-intercept is this. How much progress can I make on this thing knowing just the slope and one point? Well, I know this much. Now what can I do? How do I solve for b?
You plug in that pair.
Okay, so you get 1 equals 2 times negative 3 plus b. Notice b ends up being 7. Now I have my equation. Y equals 2x plus 7. So my question is, which is the tougher way to do it? I think they're both about equal. In other words,
Plus, as you said, the question requires that he do it in one way. So, along with checking the plus or the minus, you need to read his questions carefully.
yes, if you know that this has to be in slope-intercept format, then I would say this is the easiest way to do it. If they didn't specify and they merely said, give me the equation of the line, Well, I can get it in one step in point slope. There's the equation of the line.
That's good.
One step. The problem is that that's not in slope-intercept format. So I still have 2 or 3 things I got to do to that equation in order to get it to 2x plus 7. You have your choice as to which method to use. And I'm not sure with this problem that one is superior over the other. They both are about 4 steps to get it into slope-intercept form. And it doesn't matter whether you start with slope-intercept form or you start with point slope. Notice that both of them go to the same equation at the end, 2x plus 7. I don't think that in the previous 3 days we've worked with point slope at all, have we?
No, when we went over the notes, I didn't see it there. That's why I asked.
I wasn't even sure you had it until you just mentioned it a minute ago.
And maybe since it's not on the test, maybe it's not going to come up. But it was good to go through it so he knows how to
Well, if that's the case, then I would say always use this method. You don't want to find yourself confused in the middle of the thing between slope-intercept and point slope. So it's probably best to use the same method for all of the ones we're going over, and everything we've done has been slope-intercept method, except for the one that was in standard form, and we left it in standard form because that was by far the easiest way to figure out the intercepts. But most every other problem we're doing, we're going to go through this slope-intercept format. Okay, number 21 is the second problem that would be on an algebra test if they only could give you 2. In fact, this might be the first problem. To come up with the equation of a line when you only know 2 points. That is almost the definitive algebra problem. 2 points determine a line. So whatever the equation of the line is, we should be able to come up with it knowing 2 points. It's the first thing I need to do.
You need to figure out the slope.
Okay, what is it? Now pay very much attention to the sign of the numerator and the denominator. Don't just come up with a number. Come up with the sign first.
It'd be a negative.
So it's a positive 4 in the numerator and a negative 2 in the denominator, right?
Yeah.
So what's that simplified to?
That'd be negative 2.
Okay. Now the problem becomes the same as the previous problem. Now we have a slope and we have 2 points, but we only need 1 point. In other words, when you have a slope and a point, you can come up with the equation of the line. Which point you want to use is completely up to you. I always use the one that has the lowest numbers, the fewest negative signs in it, which means I'd probably use this point over here. So how am I going to come up with the equation of this line?
You just plug it in.
To what?
The y equal mx plus b format.
You can do it.
Tell me what the next line is.
5 equals negative 2 times 4 plus b.
Okay, you got that down pretty good. You seem to you go exactly to the right place on these kind of problems. What's the b equal to?
14 hours.
14 hours is not right. Where did that come from? Is that on your...
No, that's my Apple, the goddamn thing. It's got a mind of its own.
Oh, okay. I wasn't sure whether that was a monster in my computer or what.
We got one of these iMacs, and it really has a strong personality.
I kind of like that. That might be kind of fun. Having a dog that talks.
Yeah.
So what's b equal to here, Patrick?
13.
Yeah. So what's the equation?
Y equals negative 2x plus 13.
Okay. All right. On 22, let's not do it. Just tell me what the slope of the line's going to be.
22. Okay.
Is it going to be negative 3x?
What's the slope of this line?
3x.
No? Y equal mx plus b. M is the slope, not m times x.
So it would be 3.
Okay. So that's the slope of this line. What's the slope of the line parallel to this line?
Negative 3?
No, it's the same. Parallel means the same. Okay? You're going to get asked two kinds of questions. One is the slope of a parallel line, and the other is the slope of a perpendicular line. Parallel means the same. Perpendicular means you have to do two things. If I'm going to give you an equation. What's the slope of this line?
4.
What's the slope of a parallel line?
4.
What's the slope of a perpendicular line?
Negative 4?
Got to do two things. Remember, you don't have to do anything for the parallel line. It's the same. You have to do no processes. For the perpendicular line, you got to do two things. It's the negative flip, or it's technically the negative reciprocal. But that's harder to remember than the negative flip, the opposite flip. What's the opposite flip?
That's where you flip the
Okay, this 4 right now is the same as 4 over 1. So flip it. What do you get?
you get negative 1 over 4.
Yes.
If you
Yes, exactly. Okay.
This is because I know you're going to get them.
Well, there's definitely going to be questions about perpendicular and questions about parallel. Okay, let me give you another problem. What's the slope of the parallel line?
2 over 3. I mean, sorry.
That's right.
Nope.
You don't do anything to it. That's the slope of this line. That's also the slope of all lines that are parallel to this. It's pretty much what parallel means, is that it's the same slope. What's the slope of the perpendicular line?
Negative 3 over 10.
That's it. That's all you have to remember. Parallel is the same. Perpendicular, you got to do two things to it. What's the slope of this one, the one that's perpendicular to this?
You want 23, David?
Yeah.
A little fuzzy.
Yeah, this is y equals negative 1/2 x plus 12. Doesn't matter what the y-intercept is. What's the slope of the parallel line?
It'd be negative 1 over 10.
What's the slope of the perpendicular line?
2 over 1.
Just 2. And 1 is your denominator. You don't express it or write it. It's useful if the original slope is 2 to know that there's a 1 under that, but you don't write it.
And so on your negative flip, then that's what gets rid of that negative sign.
Yes.
Okay.
When a negative flipped negative 1/2, if you start with negative 1/2 and flip it, you get 2 over 1, change its sign, it becomes positive. So that's how you get 2 over 1, which becomes 2, without the plus sign, without the 1.
Right, and if it starts off as a positive and you did your negative flip, obviously you'd get a negative.
Yeah, you could say opposite flip maybe is a better expression than negative flip.
No, I think he's got down negative.
Okay, but I mean it turns a positive to a negative, but it turns a negative to a positive. So whatever way he remembers it is probably sufficient. All right, I'm sure you'll get a question like 24. Do you know how to do 24?
Yes.
Let's go to the next one then. I'm going to let you tell me which of these is going to give you problems and which is not. Is 25 going to give you problems?
No, I pretty much
I
got
think you
25.
do also. Well, let's do 25. Just satisfy me.
All right.
Only because of the last 2 words that you mentioned there. So we have, this is a very typical problem. Definitely one of the 2 or 3 problems they would give you if they could only give you 2 or 3. So let's come up with the equation of this line.
It would be y minus 4 equals 1 over 3 x times x minus a minus 6.
Like that?
In parentheses.
Simplify?
We have negative 4, negative.
Okay, what's the first step in simplifying an equation?
You have to distribute it.
Okay, let's do that. Get rid of the parentheses. Either get rid of the parentheses or get rid of the denominator. In this problem, getting rid of the parentheses makes the most sense. Because we're trying to solve for y. If I were to get rid of this denominator, I'd end up with 3y over here. So it doesn't make sense to get rid of this denominator, but it definitely makes sense to get rid of the parentheses. What do you got?
What's this? Just do a piece at a time. Distribute the first one.
So it would be 1 over 3x
2 of those, so that's
plus minus negative 2. I mean minus 2.
2 minuses make a plus.
So it would be plus 2.
Is that the final answer?
Yes.
What is
No,
4 over
yeah.
here? Remember, we're trying to get it into y equal mx plus b.
So it would be negative 4y.
How do I isolate the y? What am I going to do with that minus 4?
Yeah, 4.
Okay?
so what's it going to be? What's the final?
Y would equal 1 over 3x plus 6.
That's good.
There's your equation.
You understand that? Looks really good.
And I have no problem whatsoever with you using point-slope format. That's actually, to me, that's almost the superior way to do it. It's not really any shorter than starting with y equal mx plus b, but this is the one you seem to want to use. You want to use point slope when you have a point and a slope. It feels to me like. Which of these is a vertical line? Which is a horizontal line?
Well, y minus 6 would be a horizontal and x equals 2 would be a vertical.
Okay. How would I solve these two equations by graphing? Just describe it to me.
You just graph both points.
And what's the solution?
Where they cross.
Right. That's the key thing. In other words, if I have two lines, the solution is where they cross. Where whatever the x and y coordinate are at that point, that's the answer. Now, let's solve these a different way. Let's solve this algebraically. If your life depended on knowing exactly what the exact solution is, I wouldn't want to do it graphically. But I can certainly do it algebraically. How do I do it? This is a little unique. Well, you're going to use substitution or elimination?
We could use substitution. I mean, elimination.
Well, you can actually use either one fairly easily. But there's something you probably want to notice here that I want to remind you. If y equals this and y equals this, then you can always say that the one thing equals the other. Remember, this is a system of equations, so the y has to be the same thing. This y is the same as that y. So if I got y equals apples and y equals oranges, then oranges equal apples. So when you're solving two equations and they've both been determined by y, it's rare that they give it to you in this format. This is more of a set of questions they would give you and have you solve it graphically. But nonetheless, they may give you a question like this and say solve it algebraically. And just kind of remember that tip, that if you have both equations already defined as y equals something, then you can just set the first something equal to the second something. Now solve this equation. First step?
You would substitute 2x plus 5 for x.
No, we've already substituted. This is what y was equal to, and this is what y was equal to. So we've already done the substitution. Now we have to solve the equation. It's the way it always is. You end up with an equation that you have to solve. As long as there's only one variable in this thing, we can always solve it.
You might get x on one side and numbers on the other.
Doesn't matter which side you get x on. You just got to separate. You got to get all the x's on one side, isolated, and nothing but numbers on the other side.
So we get minus 5.
Okay. It's a good starting point. What's the next line?
2x equals 4x minus 8.
Okay. What now?
And then you could minus 4x.
Okay. There's nothing wrong with that. That's a perfectly acceptable thing to do. What's the next line?
Be negative 2x equals negative 8.
And the final line?
4. X equals
4. Okay. And what's y equal to?
You just plug that back in.
To either equation. So if I plug it into this one, it's very straightforward. 2 times 4 is 8, plus 5 is 13. So y is equal to 13. Okay, let's make sure you can do 31. I got...
Hey, David, quickly for a second, just to jump back. What is the standard formula that he should put on his cheat sheet for rate of change? Is that just his slope? He just said slope, so is that the correct?
Yes, it is.
Okay, great.
That's what rate of change means, exactly.
Right.
On that other problem that asks about rate of change. They're talking about slope. And if you have a series of points, and you want to know the slope of that, well, you draw a line, the best line I can draw through those points, and then you figure out the slope of that by just knowing any 2 points. In other words, I can figure out the slope of this line by analyzing from there to there, rise over run, or I can go from here to up here, rise over run. Now clearly the more distance between the 2 points I pick, the more accuracy I'm going to have. In other words, I wouldn't want to try to figure out that slope by doing the following. I wouldn't want to pick a point here and a point there. Not if I'm reading it off the graph. That's not enough accuracy to give me an accurate slope. So if I have a bunch of data points and I've drawn a line through those points and I want to figure out the slope, pick 2 points that are far apart and make sure you know this distance, that's the rise, and this distance, that's the run.
Okay, now wait a minute for a second, David. Did you want to do 33, 37, these graphs? Sorry. Okay, can we jump ahead to 33, David?
Sure.
You did run through 31, 32? Yeah, this here I can show you.
How do I plot an inequality? How do I graph a linear inequality, which is what this is? It's linear because it's just a y and an x. There's no x squared or anything. So what's the first thing I need to do in order to graph this?
You start at -4.
Okay, the first thing I need to do is to graph it as if it were an equation almost, right?
Yeah.
Okay, so we start at -4. And then what?
If you go up 3 over 1 to the right.
Correct. Now I've got my line, I've got 2 points, so I can make a line. Do I want to make it a solid line or a dotted line?
Dotted.
No, it's less than or equal to.
Oh.
Yeah, make sure you look
The only ones you make a dotted line is where it's either less than or greater than. Not when there's an equal. When there's an equal with that, it's always a solid line. Am I going to go, is my region that I need to shade, because I need to let the graph know whether I am above or below that line. Am I above or below it? And that's always the question I want you to ask. Is not right or left, not to the lower right or the upper left. One thing only. Am I above or below that line?
You're below.
Yeah, because that says less than. So find a point on the y-axis that is below that line. Well, here's a point. Here's another point. Well, both of those are in this area. So once you find a point on the y-axis that is above or below the line, that tells you the entire region you need to shade. That tells me I want to shade, you could say, to the right of the line, but it's better to think of it as above or below, because it's only the y-axis that you want to look to figure out the answer. You don't want to think of it as right or left.
And now 37.
Okay, 37 is fairly similar. The only difference between the last one and this one is there's 2 lines. So we're going to have to do them both individually, just exactly like we did the last one, and then find which area is common to both. So how do I graph the first inequality? Y is greater than or equal to minus 2x plus 4.
You'd start at 4.
Okay. 1, 2, 3, 4.
And then you could go down 2 over 1 to the right.
Good. Looks like you're getting your plus and minus solid or dotted?
Look at you.
It would be solid.
Which side of that line am I going to shade?
You're going to shade the left side.
Don't say left or right. Above or below?
So below.
What's this inequality sign say?
Y is greater than or equal to.
Greater than means above. Less than means below. Just remember those two things. You'll never miss it.
Yes. Okay.
Okay? So I pick a point on the y-axis that's above that line. Well, any of those points are. So clearly I got to shade that whole area there. The other inequality. What do I need to do to it before I can graph it?
Put it in y equals mx plus 2.
Okay, let's do that first.
So you get plus 3x.
Okay, so what does that mean?
Y is less than negative 3x plus 2. Up 3x.
Okay. Now see, I don't know what to say about that, but if I solve an equation my way, the very first thing I think of is if I have to move a term to the other side, I got to change its sign. So I'm never making that mistake you made. The only way it's possible to make that mistake, I'm not sure how, but there's two things you have to do. You have to do the opposite of what's being done. Right now it's a negative 3x, so I have to do a plus 3x to both sides. So that's one way to realize that the sign is going to change. It's never going to be the same. When you move a term to the other side of the equation, the sign always changes. So it's y less than a plus 3x minus a 2. How do I graph that?
Start at negative 2.
Slope.
You go up 3 over 1 to the left.
What kind of slope is that?
That's a positive.
That slope right there?
Start with your left.
That's a negative.
Okay, so that's not right. So I got to go up 3 in which way?
To the right.
Okay. And that's really the way to do it. Is just go up 3, go over one direction, and make sure you have your slope right. If you got the slope wrong, go the other direction. That's all you have to do. Is this a dotted line or a solid line?
It would be a dotted.
Which area of the graph do I need to shade?
Below.
Below the dotted line. Right? So if I make this really big, now notice, below the dotted line, tell me if this area, is that below the dotted line or above the dotted line?
Below.
So when I shade this second line, I have to make sure I shade all of up here, all of down there. Whoops. I forgot that my drawing tablet, if you do that, it treats it like an eraser. can you figure out the area that is in common? In other words, we had that, and we had this. The second one was a dotted line. Okay? And we were above the solid line, and we are below the dotted line. Well, that area, if I outline it, is this area right here. Can you see that? That's the area you get?
Yes.
When you go above the solid line and below the dotted line. That's the area. And it goes on to infinity. In other words, this is an infinite area. But it's bounded on the top and bottom by this over here. Okay?
Which one did you want to do last?
Can we go over 32 for our last one?
Uh-huh.
Are you sure there's, because this one here is easy. You sure there's not one in here that you don't know? Because easy, you just follow the formula.
You're going to do 32 by substitution or elimination?
Okay. All right, sorry.
Well, that's
Dave,
okay. I'm not going to do the whole problem. I just want to ask him that question.
Would it be elimination?
Yeah, and then it's, you're going to add them or subtract them?
Subtract. I mean add.
Okay, so after you add these two equations, what do you get?
You'd get 7x equals 7.
Okay.
So x equals
Like you
1.
said, your dad said this was an easy one, and it is.
That's fine. If that's the one you want to do, that's the one you want to do.
How are you on your arithmetic sequences?
I'm really good at those. I just need the formula again.
Yeah, well, and I've got that,
Okay,
David. We put that. He was good on those.
Definitely make sure that's on your cheat sheet.
Yeah, he's got the actual the sequencing. You know, how to figure out the sequencing, how to figure out if there was what's the 50th term or whatever
Okay.
that you might be.
Okay.
How many terms we went to number 47 or something
Cool.
like that.
Well, it's not.
And then I think there's also a formula he's got. What's the total of the terms? I don't know if they asked that, but I think there's 4 different ones he has.
Okay. These piecewise functions, where do I begin?
With those ones on number 40 or 41?
40 and 41. Well, no, 41.
You'd start, well, at 0.
Actually not.
Oh, you'd start at the 1 and 2.
I start on this side over here. Okay? I'm going to start at the upper right. This tells me that everywhere from negative infinity to 0, this is my function. So when I say where am I going to start, I mean how am I going to approach the problem? I'm going to approach it from left to right. So the first thing I'm going to do is pay attention to this area of the graph because x is less than or equal to 0. So when I say where I'm going to start, always start over here and then figure out, okay, well, what is this? That starts at 1, negative slope, and it stops right there with a closed circle. Now, the next place I'm going to consider is this, everywhere in this region. In other words, when I say where am I going to start, I mean go from left to right and what the x values are, this area of the piecewise functions. So now all I have to do is graph this function, but make sure my graph is only to the right of the y-axis. Well, it starts at -2, has a slope of 3, open dot because it's greater than, not greater than or equal. There's my piecewise function. Up in this one here, I would start the area, the very first area that I would want to consider would be, I would go over to 3. It's all this area right here. This is where I'm concerned with. That's how I start the problem. If my attempt is to graph this, that's not what this question is, but if I were to graph this, I would be concerned with how I make my graph up to that point right there. Then I'm going to pay attention to this part of the graph, where x is greater than or equal to 3. All right. Well, I'll give you this much, Patrick, an A for effort. You've put in some good hours here working on this stuff.
And, you know, from going through it yesterday and last night, he's made some progress, David. If I can get him to slow down and follow what, you know, what we've done and what you're doing.
I agree. Slowing down is key. A few times where I've seen him make mistakes, it's usually he's going a little too fast.
Yep. He just needs to slow down and follow the stuff that we gave him. Because we'll just have to see how it goes from there. Now, you know, at one time, David, you had some availability at 8:15. I was going to see with him over the next couple of hours. Do you have that time still available at 8:15 for a half hour or so? You had anything you wanted to polish up?
I don't. I am booked solid to 8:45.
That's it. I figured that it would go, David, and Patrick's rejoicing. So if you could send me a final invoice, David, I'll take care of that, and I'll let you know how it turns out.
I'll do it.
But we really appreciate your help.
I'll do it. And both of you enjoy Christmas, and maybe I'll talk to you next year.
Oh, yeah, you definitely will, but you've been a lifesaver, David. Thanks a lot.
Okay, David. Good talking to you, Patrick. Have a good one.